Okay, this is a short little video where I preview what is to come. You're going to eventually have to factor expressions in equations to solve them that have higher order exponents, meaning that it's higher than a 2. Like here, the highest exponent's to the 5th. Now, there are two terms here, so I just set up my GCF DOPS. Now the GCF, we had a negative in front, so we have negative. X, they both have X. I have X a fifth and X, so I take the X, just like I've always done. Then the GCF of 4 and 64 is 4. So I undistribute negative 4X. Now what has happened here is negative 4 divided by negative 4 is 1, but it's X to the 5th divided by X. Well, again, that's like 5 minus 1. So that's 4. So it's X to the 4th instead of to just X. Now, 64 divided by negative 4 is negative 16. So minus 16. And then the X's here are the same. So they cancel. So far, just a little bit of variation. Remember, you don't just write X if it's to the 5th or something else other than 2. Now, here's how I check for a DOPS here. We got to be careful. We have our minus, and 16 is a perfect square. That is 4 times 4, okay? And 1's a perfect square. That's 1 times 1. But x to the 4th is not x times x. X to the 4th would be x to the 2nd times x to the 2nd, okay? So then I put 1x to the 2nd, 1x to the 2nd, and then 4 and 4. Now, the one that has a plus sign, you need to circle that. You don't do anything else with that. But the one you have as a minus sign, we need to see if that's another difference of perfect squares. We have minus, and 4 is, that's 2 times 2. 1 is, that's 1 times 1. And x to the 2nd is x and x, okay? It's like for x of first, x of first. So I make another DOPS, and I put 1x, 1x, and then 2, 2. Remember the rule, if it has a plus sign, circle it. This has a minus, but 2 is not a perfect square, so that can be circled as well. As soon as I circled everything, that is how to do it. All this is a warm-up to get when we get to the stuff, it's not quite as hard. Now my next problem, I have 1x to the 4th power minus 7x to the 2nd power minus 18. Now there's no negative in front. We don't have x on everything. 1, 7, and 18 is a GCF of 1, so I didn't do that. I did my ABC just like normal. A is 1, B is 7, C is negative 18. So A times C, okay? 1 times negative 18 is negative 18, so it's a difference of 7. And I found it for you. 2 and 9. 7's minus, so minus 9. And it's a difference. The signs are different. Now, your A is 1x to the 4th. It's not 1x to the 2nd. Now, A is 1, so I just need one line of parentheses. But I don't put x. We have x to the 4th. So we need to cut the exponent in half. So it's x to the 2nd, x to the 2nd. And then I put the plus 2, the minus 9. Now, we still have powers on these x's. If we have a plus, we circle it. We can't break that down any further. But if we have a minus, we need to see if that's a DOPS. And it is, because you got 3 times 3 and x times x. It's to the 2nd, so it's just x times x. So I make the plus minus, and then x, 3, 3. The plus can be circled. The minus, x doesn't even have a power, so that can't be done. So that's finished, okay? So with these higher powers than 2, you got to look after you're done. You got to really pay attention to that. Now my next problem, 3x to the fourth minus 2x to the second minus 8. So the GCF here, it's 1. You don't have a negative. You don't have x belonging to everything. And then 1. Okay, so I did the ABC. So again, I take A times C. 3 times negative 8 is negative 24. So difference of 2. And I find it, 4 and 6. My 2's minus, so that 6 is minus, and difference means they're different signs, so that's plus. Now, A is 3x to the fourth, so I didn't have a 1 there, so that's why we made 2 lines. And I lead off with the 3 just like I normally would. But we have x to the fourth, so we have to split that in half. Because usually it's x second. Well, splitting an x to the second in half is just an x in each one. But if I split an x to the fourth in half, it's x second and x second. Then I plus 4 minus 6 from here. Now 3 and 4 the GCF's 1, so that stays 3x to the second plus 4. 3 and 6 the GCF's 3. So that is 1x to the second minus 2. Now the plus is circled. The minus, but 2 is not a perfect square, so that's circled. So I can go no further with that. Okay, in our next problem, there are 2 terms, so GCF DOPS. In the GCF, we did have a negative in front, and we did have x on both. We have x to the fifth and x, so I put x. And then 2 and 18's 2 as the GCF. So I have factored out negative 2x. I went up and divided. I get positive 1. Now x to the fifth divided by x is x to the fourth. Then 18 divided by negative 2 is negative 9. So minus 9. And those x's, since they're the same, can be crossed out. Now we see if we have a DOPS. You have minus. 9's 3 by 3. And 1 is 1 by 1. Now, x to the fourth means you break it in half. So it's x second, x second. Now, some people are wondering, what if the exponent's odd? You can't break an odd number in half, so you wouldn't do it. It wouldn't be a difference of perfect squares, but this is. So I put 1x to the second, 1x to the second, and then 3 and 3. The plus is circled, because that's done. That's a final factor. We have a minus here, but 3 is not a perfect square, okay? Because I got 1 times 1, x, but I can't do much with the 3. And the reason why that's just x and x, because it's to the second. When you get to the second, you break them up into just x and x. Okay, let's keep on rolling here. I have 1x to the fifth minus 2x to the third minus 1x, okay? The GCF here, well, you didn't have a negative in front. You did have x on everything, though. X fifth, x third, and x. So I take the x, and then 1, 2, and 24 is just 1. But that's 1x, so I do need to factor out 1x. Then I go divide by 1x, but that's 1. But x fifth divided by x is x to the fourth. Minus 2. X third divided by x is x to the second. And then these x's go bye-bye. It's just 24. Then I did the t-chart. A, B, C. 1 times negative 24. Negative 24, difference of 2. That's 4 and 6. Now 2's minus, so 6 is minus and plus. You just kind of have to look through all the bull crap here. Now A is 1, but it's x to the fourth, okay? Now, A is 1, so I can get by with just 1 line. I don't need 2, okay? I don't need to lead off with 1, okay? But it's x to the fourth. Well, we need to break that in half, and it's x to the second and x to the second. And then plus 4 minus 6. The plus gets circled. The minus has to be checked for a difference of perfect squares. You have the minus. And X squared would be, if it's just to the seconds, X times X, but 6 is not a perfect square. So that allows me to just circle that. And if I circle everything, then I don't go any further. Okay, the next one, negative 3x to the fifth plus 75x. So there are two terms. That's why you see this setup. So the GCF, you have a negative in front. You have x on both, x fifth and x, so I use x. 3 and 75 have a GCF of 3, so you see a negative 3x has been factored out. Then I go up and divide all the terms by negative 3x, so that gives me 1. But x to the fifth divided by x goes to x to the fourth. And 75 divided by negative 3 is negative 25. So I put minus 25, and those x's are the same, so they cancel. Now DOPS, minus, well, 25 is 5 times 5. So we're good there. The 1. 1 is 1 times 1. That's pretty obvious. Okay. And then do we have an even power on that x? You do. So split it in half. X second, x second. So you're not going to put 1x, 1x. It's going to be 1x to the second, 1x to the second, and 5. So the plus gets circled and don't even think about it. We have a minus, but I don't think 5 is a perfect square, so good. Okay, now on the next part. Negative 7x to the fifth plus 28x to the third. So it's two terms, GCF DOPS. Now take a look at this. You have a negative in front. And you have x on both, but here's the deal. You have x to the fifth and x to the third. You don't have just regular x anywhere. You write x to the third, the smaller power. I know greatest common factor, you'd think it's the greatest. It's actually not on the x, it's the smaller, okay? Because it's like you're taking it away. You can't take away 5 from 3, okay? And then the GCF of 7 and 28 is 7. So I factor out negative 7x to the third. And then I go up and divide. Now these are going to cancel because they're the same. That's 1. X fifth, x third would be x to the second. It's just basic subtraction. And that's negative 4, hence the minus. And that's, there it is. DOPS, well, we have minus. And 4 is 2 times 2. 1 is 1 times 1. And is that an even power? It's to the second, so that would be just x. Because it would be technically 1 and 1, but x of first is just x. So I put 1x, and 2, and 2. The plus may be circled. The minus can be circled because I have a minus, but 2 would not be a perfect square. It's not up on the board. So there we have it. Now, so I know I haven't been doing it, but you are going to want to circle the GCF too. Okay, now my next one. 48x to the third plus 16x. GCF. You don't have the negative. You have x on both. You have an x third and an x, so we take just the x. 48 and 16, the GCF 16. So I factor out 16x. 48 divided by 16 is 3. But it's x third divided by x, so that and these cancel. All that does is take the third power to a second power. Takes it down 1. Plus 1. DOPS. Well, I got a plus here. And so I just circle it. I'm not going to do anything there. And we're going to want to circle the GCF.